Hi guys, so today we have the PYQ from 5th April Shift 1 of JEE Mains 2026. So it's from the topic of coordinate systems in the chapter of straight lines. So let's see the question. It says in the equilateral triangle PQR, let the vertex P be at point 3, 5. So let's draw while reading the question. So let's this be the y-axis and this be the x-axis, and this will be the point some P, that is 3 comma 5. Next it says, and the side QR be along the line x plus y is equal to 4. So let this be the line x plus y is equal to 4, and it says it's an equal triangle and the QR lies on this x plus y equal to 4 line. So this is Q and let this be R. And now he says the orthocentre of PQR is alpha comma beta. Then the value of 9 into alpha comma beta is, sorry, alpha plus beta is. So let this be the orthocentre H, that is we need to find. That is alpha comma beta. So what you're going to do is, since the orthocentre divides the perpendicular line from any vertex into 2:1 ratio, so what we'll do is we'll find a foot of perpendicular to this point, and let that perpendicular foot of perpendicular be m. So let's write here. So let this be pm and this be the h, that is alpha comma beta that we need to find, and this will be 2:1 ratio, so that we can find the alpha comma beta. So P we know it as 3 comma 5, and we will find the m, that is the foot of perpendicular from point 3 comma 5 onto the line x plus y is equal to 4, and let the some m point be x comma y. So let's first find the foot of perpendicular. We know the foot of perpendicular formula, that is x minus x1 by a is equal to y minus, so let's write it down, x minus x1 by a is equal to y minus y1 by b is equal to minus of a into x1 plus b into y1 plus c by a square plus b square. So we know this formula, and now let's substitute the values. So now x1 comma y1 is equal to 3 comma 5, that is the top point, and the equation, that is x plus y minus 4, that actually represents the ax plus by plus c. So if I compare, a is equal to 1, b is equal to 1, but c equal to minus 4. From this, x1 equal to 3 and y1 equal to 5, and let's substitute all these values in the formula to find the point m, that is the foot of perpendicular. So x minus 3 by 1 is equal to y minus y1 is 5 by b equal to 1 is equal to minus of a into x1, so 1 into 3, that is 3, plus b into y1, so 1 into 5, that is 5, plus c equal to minus 4 by a square plus b square, that is 1 square plus 1 square. So we have x minus 3 is equal to y minus 5 is equal to 3 plus 5 is 8, 8 minus 4 is 4. So we have minus 4 by 2, that is minus 2. Now to find x, so x minus 3 equal to minus 2 and y minus 5 equal to minus 2. So x we have is as 3 minus 2, that is x equal to 1, and y is equal to 5 minus 2, that is y equal to 3. So we found point m, that is 1 comma 3, and now we have p, we have m, and we simply need to apply the formula of the section formula to find the point h, that is the orthocenter of this triangle. So let's do it this side. So the section formula is the internal section formula. The h is m into x2. So here let this be x1 y1 and this is x2, that is sorry, x2 y2, and we are doing it m is to n. So m into x2, that is 2 into 1, that is 2, plus n into x1, that is 1 into 3, that is 3, by m plus n, 3, and comma m into y2, that is 2 3s are 6, plus n into y1, that is 1 to 5 is 5, by 3. So we have orthocenter, that is 5 by 3 comma 11 by 3. So what they asked, we found alpha and beta. Now they asked 9 into alpha plus beta. So 9 into 5 by 3 plus 11 by 3. So we have 9 into 5 plus 11 by 3. 3 3s are 9. So we have 3 into 14, sorry 16, 3 into 16, that is 48. That's it. So we found the 9 into alpha plus beta, that is 48. So first what we did is we found, since we know the property that the orthocenter divides the altitude from a point to base into 2:1 ratio. Therefore we found the foot of perpendicular, and we, with using the section formula, we found the orthocenter, and we added the alpha and beta of the orthocenter in multiply 9, because that's what the question asked. So 9 into alpha plus beta is 48. 48 is the answer. That's it. Thank you. Subscribe for more such solutions.